The most important thing that we can do when we have to solve absolute value equations is to get the absolute value bars by themselves. So that's what you want to think about first. To do that, we're going to add 3 to both sides, and we get the absolute value of 6 plus p is equal to 6. Once we have that, we realize that we can split this up into 2 equations. Either 6 plus p is equal to the positive 6, or 6 plus p equals negative 6. Then we just solve each resulting equation for p. We get, in the first equation, by subtracting 6 from both sides, we get p is equal to 0, or if we subtract 6 from both sides in the other equation, we get p is equal to negative 12. Now, if we check p equals 0 in the original equation, we get negative 3 plus the absolute value of 6 plus 0. Is that equal to 3? Well, negative 3 plus the absolute value of 6 plus 0 is the absolute value of 6, which is 6. Does that equal 3? Yes, negative 3 and 6 is 3, and 3 is equal to 3. The other one, if we check p equals negative 12 in the original equation, we get negative 3 plus the absolute value of 6 plus negative 12. Is that equal to 3? Well, we have to simplify what's inside the absolute value bars, and when we add 6 to negative 12, we get negative 6. And so again, is that equal to 3? Negative 3 plus the absolute value of negative 6 is positive 6. So just like the last equation, we have 3 is equal to 3. Check. So just to reiterate, the 2 solutions that we found are p equals 0 and p equals negative 12. These are the 2 solutions because, as we just saw, both 0 and negative 12 make the original equation true. In fact, they are the only real numbers that make the original equation true, so therefore they are the only solutions to this absolute value equation. As you'll notice, for probably all of these equations, you'll see that we get 2 solutions. So when you ever solve an absolute value equation and you don't get 2 solutions, then make sure you double check your work. You're not always going to get 2 solutions, but you most of the time do, if they do in fact, the equations do in fact have a solution. You'll probably find 2. So I'm going to go ahead and just knock out these other ones without the check. I'll leave the check for you. And what you could do is you could just pause the video now and see if you can solve the equations that I'll be solving here in the video. So when we solve this equation for p, we subtract 1 from both sides. P minus 6 in the absolute value bars is equal to 2. That gives us 2 equations. P minus 6 equals positive 2. And the other equation would be p equals 6 equals negative 2. Because keep in mind, the absolute value of a number means the distance from 0. So if, just to give you a visual of this, if the absolute value of something is equal to 2, it means that that something, in this case p minus 6, is either equal to negative 2, so you go 2 units to the right, or p minus 6 is equal to negative 2. I think I might have said negative 2 right there. I could be wrong. But either p minus 6 equals 2 or p minus 6 equals negative 2, and those are the 2 equations that we get. And when we add 6 to both sides, here we get p equals 8. And adding 6 to both sides over in this equation, we get p is equal to 4. And we get the 2 solutions, p equals 8 and p equals 4. I just realized that my volume may have been up a little high, so I'm going to go ahead and turn that down a little bit. Problem number 3, we see we have an 8 on the outside of the bars, which means 8 is being multiplied by the absolute value of n plus 5. So since 8 is being multiplied, or 8 is multiplying that absolute value, then we're going to go ahead and divide both sides by 8. And when we divide both sides by 8, we get the absolute value of n plus 5 is equal to 2. And again, we're going to split this up into 2 equations. Either n plus 5 equals positive 2, or n plus 5 equals negative 2. Solving the resulting equation, we subtract 5 from both sides, and we get n equals negative 3. Subtracting 5 from both sides over here, we get n equals -7. As you can see, I gave you way more detail in the first example than all these other examples, because I think what you start to see here is you start to see a pattern. And if you really want all that detail, then go back to the first equation. Adding or subtracting 2 from both sides over here, we get absolute value of v plus 7 equals 1. And giving us two equations, v plus 7 equals +1, or v plus 7 equals -1. Either one of these equations gives us a solution, one of the solutions to the equation, the original equation. So subtracting 7 from both sides over here, we get v is equal to -8. So we get two solutions, -6 and -8. Well, it looks like number 5 through 8, actually, we crank it up a notch. We've got a couple steps here in each one of these equations, so I will give you a little bit more detail here for number 5. In number 5, the first thing we're going to do is we're going to add 1 to both sides. So what we want to try to do in most equations is the numbers that are being added or subtracted to both sides, we're going to get rid of those first, meaning move them to the other side, which frees us up to then divide by 4 on both sides. If we were to divide by 4 first, what you would see is, okay, the initial term here, 4 times the absolute value of x minus 9, the 4 would be divided out, but then if you divided the 1 by 4, then you get a fraction. Same with the 27 divided by 4. You don't want to get a fraction here. You want to try to avoid getting any fractions the best you can. And if we add 1 to both sides, we end up not getting any fractions at all, even when we divide both sides by 4 after that first step. So once we divide both sides by 4, we then get the absolute value of x minus 9 is equal to 28 divided by 4 is 7, which then gets us back to the two equations. Either x minus 9 equals +7 or x minus 9 equals -7. And then adding 9 to both sides, we get x equals 16, or adding 9 to both sides over here, 9 plus -7 is equal to 2. So we get two solutions when we have absolute value, an absolute value equation. Okay, let me leave that there so you can see it. All right, so try to anticipate what I'm going to be doing here. I'm going to add 3 to both sides. Okay, and we do that because if we just started this problem by dividing by 8, that wouldn't be so good, because then we'd get a couple fractions over here. We don't want to get fractions. We want to avoid that. Now we can divide by 8 once we get that 3 moved to the other side. And as you can see, hopefully you know your multiplication tables here. The absolute value of m plus 10 equals 72 divided by 8. 7 and 2 is 9. And 9 goes into 72 8 times, so 9 times 8 is 72, so 72 divided by 8 is 9. And then we get our two equations. See, once we have our absolute value bars by themselves, we set our what's inside the absolute value bars to the positive right side, +9, and then we set what's inside the absolute value bars to the -9. And then subtracting 10 from both sides, we get m equals -1, and we get m equals -19. Okay, try to keep the videos under 10 minutes. And getting there. So problem number 7, we're going to go ahead and add 4 to both sides, and then we get 6 times the absolute value of r plus 4 is equal to 72. -4 and +4 cancel. And then we go ahead and divide both sides by 6, and we get the absolute value of r plus 4 because the 6's cancel. Absolute value of r plus 4 equals 72 divided by 6, that's 12. And again, we get back to our absolute value of something equals something, and r plus 4 equals +12, or r plus 4 equals -12. If by chance you had r plus 4 equals a negative number in absolute values and bars, that would have no solution. Okay, -4 from both sides, and we get r equals 8. And subtracting 4 from both sides over here, we get r equals -16. Oh, you can't see that. Shoot, I gotta zoom out a little bit. There we go. Okay. Sorry, you couldn't see that. And then r equals 8, r equals negative 16, which brings us to just past the 10-minute mark. We can start this, adding 2 to both sides. We get 7 times the absolute value of 5 plus n is equal to 63. Dividing both sides by 7 gives us the absolute value of 5 plus n equals 63 divided by 7 is 9. And once again, we have our two equations. Subtracting 5 from both sides, we get n equals 4. Subtracting 5 from both sides here, we get n equals negative 14. So there you go. That's how you solve absolute value equations.